I just have a few announcements before we get started with tonight's speaker. First and foremost, I'm just using this as an opportunity to reach people that may not have heard the word, but Cowiche Canyon Conservancy trails, or almost all of them, are officially closed as of today. So as tempting as it is to get out in the sun, they're really muddy, and it's the most important time of year for us to keep people off the trails and prevent trail damage just until they dry out for about a week or so. So if you really want to get out on CCC land, you can still get out on the main trail that runs through the canyon, but everything else is closed due to mud in the short term. And we'll fix that as soon as we can. We want people to use the trails. It's just dangerous and bad for the trails to do so now. So that's that. The other thing, like Matthew said, please be respectful with your comments. And if you have questions, the way we're doing it is put the questions in the chat so you're not interrupting the speaker. And I'm going to do my best to collate them. I may combine similar questions if they're similar in theme, and pose those to Zach at the end of the talk. Yes, that's it. Put your questions in the chat. Tonight's speaker, I'm really excited to have a hyper-local speaker as part of our series with YVC. Zach Schierl is a YVC teacher. He teaches astronomy and geology there. And I have to say, he's been one of our most, if not the most valuable volunteer and personal partners with CCC in the last couple months. He's done multiple walks recently to share his knowledge with folks, a geology walk a month or so ago. And we thought tonight would be a nice opportunity to advertise for an upcoming, what we're calling a stargazing party at Snow Mountain Ranch, which actually is not going to be a walk. It's going to be a stargazing event at Snow Mountain Ranch parking lot on Wednesday, March 2nd. So if you all want to sign up for that, I imagine it will fill up quickly. So check out details on CCC's website under the outings and events. And I'm excited to kick it over to Zach Schierl. Zach.
All right. Well, thank you everyone for, I was going to say thanks for coming out tonight, but I guess thanks for logging on. Makes it a little bit easier to bring lots of folks in. So let's see if I can share my screen here. All right, is that showing up now? Sai, is that working? Or Matthew? Matthew, thumbs up from Matthew. All right, maybe. Still there? Okay, great. Well, again, it's great to be here. Thanks, Sai, for inviting me to talk a little bit about darkness and light pollution this evening. So the talk title, which I have to credit Sai for, is Who's Afraid of the Light? A Natural History of Darkness. So I want to start off with a question for all of you this evening, and that is, who's afraid of the dark? Let me kind of refine my question a little bit here. Tonight, when I kind of use the word dark tonight, not really talking about the kind of darkness you experience when you turn off the lights and go to bed in the comfort of your own home at night. That's not the kind of darkness we're talking about tonight. What I mean by dark is sort of what you would experience if you were to go for a walk in the woods or through the desert alone on a clear, moonless night in a remote area far from the glow of city lights, with no cell phone, no flashlight, no candle, no torch, or any other kind of form of illumination, right? The kind of dark that you would experience in a natural nighttime environment outdoors. And when we kind of think about it that way, you might be afraid of the dark. Maybe you should be afraid of the dark, right? Nothing to be ashamed of. It's completely natural for humans to be scared of the dark. We are not and never have been nocturnal animals. We can't see very well at night. We don't have a highly sensitive sense of smell or hearing like many nocturnal animals do. Our bodies really aren't designed to function in the dark. So humans have sort of been using light to ward off the night for thousands of years. It's one of the things that makes us humans. So we started with fire. Then over time, we harnessed that light into more controllable forms like candles, whale oil lamps, gas lamps, and then eventually the electric light bulb. Few inventions have kind of reshaped the human experience as much as the electric light bulb. Today we can have immense amount of light wherever and whenever we want, using very little energy, just with the flick of a switch or the press of a button. We have tons of options for lighting our homes, our streets, our businesses. Here's a picture of the light bulb aisle at Home Depot. It's kind of crazy how many options we have for electric lighting these days. So because of this thing, the light bulb, very few of us ever experience anything really resembling true darkness or natural darkness on any regular basis, especially if we live in a city. Given our kind of inherent fear of the darkness, that might seem like a good thing, right? We've defeated the darkness, yes. And in some ways it is, but we are kind of beginning to recognize that all of this light has consequences. Consequences for us as humans, consequences for the natural world around us, consequences for our ability to engage in astronomy and study the universe. And that's kind of what my talk this evening is about, the loss of natural darkness and the consequences that go along with that. So this is going to be kind of a wide-ranging talk. This is a really interdisciplinary subject. I'm going to be kind of touching on everything tonight, from astronomy to urban planning to ecology to medicine. My background is as a geologist and an astronomer. So this talk is going to have a little bit of an astronomical bent to it, simply because that's kind of what I'm familiar with and how I got interested in this topic. But also because the night sky is probably the most visual or visible casualty of too much light. So that's where we're going to kind of start off this evening. So you've probably noticed if you live in a city, you can't see as many stars as you can from a remote area. So this is a photo right here of the constellation Sagittarius, taken from a relatively dark place. So let's see if I can, well, let me draw here. Yeah, so here's the constellation Sagittarius. Sagittarius is supposed to look like a centaur archer, but most constellations don't really look like what they're supposed to. We generally call Sagittarius the teapot instead. It does kind of look like a teapot, right? There's the handle, there's the spout. And notice kind of in the background here, all this fuzzy stuff in here. That is our Milky Way galaxy. In fact, right about there is the very center. You're looking towards the very center of the Milky Way. So this is the constellation Sagittarius in the Milky Way from a dark location. Here's a photo of the exact same part of the sky, only this time from a small city of about 30,000 people. Exact same camera settings, same sky conditions, a clear night. Really the only difference here is now we're taking this photo from a more populated area. And you can see that there's quite a difference, right, due purely to those city lights. This was not a large urban area. This was kind of an Ellensburg-sized town. Notice that the Milky Way is basically, you can't see it anymore. A lot of the fainter stars have been washed out. So it doesn't take a whole lot of human light or city light to really impact our view of the night sky. And so this is a problem that astronomers have been dealing with for a long time, really since the very early days of electric lighting over a century ago. So just kind of diving into history a little bit here, back in the late 1800s, the astronomer Percival Lowell, who is famous for his belief that there was an intelligent civilization of canal building Martians on Mars, fun topic for another talk. He was sort of the first astronomer to to get really fed up with artificial light ruining the view of the sky. Lowell was from Boston, and the urban areas of the Northeast and New England were, by the late 1890s, becoming increasingly lit and increasingly polluted. A bit later in 1906, Lowell wrote the following: "Not only is civilized man actively engaged in defacing such part of the Earth's surface as he comes into contact with, he is equally busy blotting out the sky. In the latter uncommendable pursuit, he has in the last quarter of a century made surprising progress." Right? So this is over 100 years ago. Astronomers are already getting frustrated with not being able to see the sky. So Lowell set out for the American West in search of a dark, high altitude, unpolluted place to study the sky, to take up astronomy. Lowell was rich, so he could do that pretty easily. There is a town named for Lowell's family in Massachusetts, Lowell, Massachusetts. If you have a whole city named for you, you're probably pretty well off. So he sort of packed up shop and eventually settled on a little train stop town in Arizona called Flagstaff to establish his observatory. So in 1894, he established his own observatory, Lowell Observatory.
Zach, we lost your audio.
Oh, better now?
Better now, thank you.
Okay, I hit the mute button.
No worries.
So all of this is just to say that astronomers were sort of the first on the scene when it came to the disappearing dark, for very practical reasons. They couldn't see anything. As recently as the 1970s and 1980s, astronomers were really still the only scientists concerned with the disappearance of darkness. And in a little bit, we'll talk about kind of how and why that changed. But first, let's kind of take a closer look at why natural darkness is disappearing. So this is an image of the United States at night from a satellite. So this is called the Suomi NPP satellite. It's a joint satellite operated by NASA and NOAA. It was actually originally built and launched to monitor climate. It's a climate and weather satellite. But it turns out that it's been really useful for studying human light emissions as well over the past few decades. So you are here, assuming that you are here in Yakima, and we can see the city lights from cities all across the country. So we've got Seattle right here, Portland, San Francisco, Los Angeles, Salt Lake City, Denver, etc. And think a moment for about kind of what you're seeing here. Right? This satellite is 500 miles above the surface of the Earth, and it's capturing all of this light shining up into the sky. Right? If you can see this light from 500 miles overhead, that light, those photons probably aren't doing us a whole lot of good here on the ground. We need light at night, right? Not disputing that. Our modern society depends on having light at night. But with few exceptions, we need that light on the ground, on roads, buildings, sidewalks. What we're seeing here is light that's shining up into the sky. Now, some of that is reflected off of the ground and bounced back up into the sky, but studies have shown that the majority of what you're seeing in satellite images like this is light that we shine just straight up into the sky. Sort of like having your garden hose on full blast and having it go straight into a storm drain. The majority of what you're seeing here is wasted light, wasted energy, wasted money, ultimately. So this is what we call light pollution. Light pollution is unnecessary, unwanted, or excess light that is created by humans. Now, this map kind of makes it look like, well, maybe things aren't so bad, right? There's lots of pretty dark places still, especially in sort of the western half of the country here, right? This is really just a city problem, right? Unfortunately, that's not really the case. That this image here is a little bit deceptive. That image was made by a satellite, basically passing overhead and taking a picture of the light that goes straight up into space from sources here on Earth. However, a lot of the light that we shine up into the sky doesn't ever get to the satellite. Earth has an atmosphere that contains gas molecules, dust, smog, particles, all sorts of other stuff. And so when we shine light up into the sky, a lot of it never reaches that satellite. A lot of the light that we shine up into the sky reflects or scatters off of all of the stuff in our atmosphere and essentially gets reflected back down towards the ground, creating something that we call sky glow. Sky glow is why you can see the lights of a major city from miles and miles away. We used to live in southern Utah before moving to Yakima, a couple hours north of Las Vegas. And you could clearly see the sky glow of Las Vegas from about 2 hours away easily. Now, Las Vegas is sort of the light pollution capital of the world, but this is true of other cities as well. Kind of a local example here, a few years ago, the Yakima Herald published this photo of the night sky, which was taken from out at Weenus Lake. And the article originally said that that glow on the horizon was the northern lights. Unfortunately, that's not the northern lights. It's the wrong color, kind of the wrong direction. What you're actually seeing here is the sky glow of Seattle from here in the Yakima Valley. So I sent them an email gently explaining this, and a few hours later they had corrected the article to say not the northern lights, but light pollution from Seattle, right? So we're a couple-hour drive from Seattle. We can easily see the sky glow from Seattle from here in central Washington on a clear night. So when you take into account sky glow, the US looks more like this. So the colors on this map of the United States, this is basically the same image we just looked at, only now the colors are representing sky glow. They're representing the amount of sky glow at the zenith. The zenith is, if you go outside and look up at the sky and you look straight up, the zenith is the point in the sky, basically straight over your head. So the colors here are representing the amount of sky glow at the zenith on a clear night. The clear part is important. Sky glow is much worse when there are clouds in the sky, right? Because it's just more particles for light to bounce off of and light up the sky. So this is sort of a best case scenario, if you will, here. And so in this map, only the areas that are colorless, that are black, those are the only areas where the night sky is basically unaffected by sky glow at the zenith, where there's almost no light pollution whatsoever. And so as you can see, sort of true natural darkness really doesn't exist anywhere in the eastern half of our country. The only places that have kind of anything resembling natural darkness remaining are like portions of the Colorado Plateau in the southwest, the Big Bend country down in Texas, portions of the Great Basin in eastern Oregon and Nevada, maybe some portions of Montana up here, but that's about it. Once you get into the yellow zone on this map, you can't see the Milky Way anymore. So in fact, only about a quarter of Americans can see the Milky Way from their home. Let's zoom in on Washington here for kind of a closer look. There's almost no true darkness anywhere in Washington. Maybe a little bit up here in the Pasayten Wilderness, up near the Canadian border. It's pretty dark down in the like the Mount Adams area down here. But it's kind of interesting if you think about sort of the Cascades, right? We think of the Cascades as being kind of remote and wild, but from a darkness standpoint, they're really just sandwiched between the light pollution of Seattle and then all of the lights that we have here in central Washington. Again, the colors are representing essentially the intensity of light pollution here. So notice that light pollution here in Yakima or in the Tri-Cities, it's almost as bad as downtown Seattle in terms of intensity. It's covering a smaller area. But the light pollution in even the smaller cities that we have here in central Washington is pretty intense. We can zoom in a little bit more on central Washington and the Yakima Valley here, and you can kind of clearly see all of the different population centers in our area. So let's go back to the national map here. A couple takeaways, I think, from these maps, right? Obviously, there's a correlation here between light pollution and people, right? More people, more light pollution, but it's not as strong of a correlation as you might think. We're going to talk about that a little bit more later. There are places that have a lot of people, but substantially less light pollution than other cities their size. So this is not purely a map of population or where people are. A great example is this blob up here in North Dakota. Not that many people up there in North Dakota. That is all light pollution from oil and gas development in the Dakotas and southern Canada. The other thing that's really important about these maps is just to kind of highlight why we make maps like this and why they're important. These maps are really important scientifically. Anytime we observe a change in the environment, it's really important to be able to quantify that change, right? Whether it's air pollution or water pollution or light pollution. In order to approach this from sort of a scientific standpoint, we need to be able to say, okay, how bad is the problem? How is it changing over time? And these measurements that are based mostly on satellite data allow us to do that. So a little bit later, I'm gonna talk more about how we make these maps, how we measure light pollution. But first, I want to shift gears a little bit and talk about the importance of darkness and some of the effects that all of this light has on the natural world. Let's just start by thinking a little bit about how unnatural it is to have a world that is lit up at night. Our planet has been around for 4.56 billion years, give or take a few 100,000 years. And throughout Earth's history, Earth has really been a planet of constant change, right? Our continents, our tectonic plates merge and drift and split apart. Weathering and erosion are constantly reshaping Earth's surface. Global temperatures and our climate changes throughout geologic time. But aside from the occasional big volcanic eruption or asteroid impact, most of these changes occur slowly enough that life on Earth has been able to evolve and adapt over time. One of the few things that really hasn't changed very much, one of the few constants, I guess you could say, across geologic time has been the natural cycle of light and dark that is produced by the rotation of our Earth, right? So our planet rotates, that causes the sun to rise and set each day. That's what produces day and night. And so for eons, for billions of years, right, we have had day followed by night, right? Light followed by dark. And it's really remarkable how little that cycle has changed. The length of our day has actually increased by just 3 hours since the Cambrian period 541 million years ago. Right? So these natural cycles of light and dark on our planet are quite constant, and they're really something that kind of every organism that has ever existed on our planet has experienced to some degree. It's only been in the past 100 years of Earth's 4.5 billion year history that we have started to disrupt that cycle. Right now, the night, right, that the dark looks like this from vast swaths of our planet. This is a photo of the light pollution over Yakima Valley, taken from out in West Valley, out towards Cowiche Canyon. we've really eliminated or degraded the darkness from just vast swaths of our planet in a pretty short amount of time, right? There's really no analogous phenomenon in the history of our planet, right? There's no real good analog for getting rid of the dark the way that we have in the last century or so. The closest analog, really the only natural source of bright light at night, is the moon. So this is another nighttime photo here, but the light, the glow that you're seeing in this photo is not sky glow, not light pollution, but moonlight. So we have a roughly week-long period of bright moonlight each month, where our nights are not quite as dark as they are otherwise. Again, this is a natural cycle. The moon's been here for more than 4 billion years. We've had full moons for a long, long time. But one of the things that we've learned from the sky glow maps that I was showing you earlier, one of the things that we've learned from measuring light pollution is that sky glow, especially when combined with clouds or snow cover, sky glow can rival or exceed the full moon in brightness, right? The degree to which we are lighting up the night in many cases is greater than the degree to which our natural source of light, the moon, lights up the night sky. This is interesting because we've known for a long time that moonlight affects animal behavior. And so the question is, might light pollution as well? Might all of this ambient light that humans are creating in the environment affect organisms in the natural world around us, especially given kind of how recent and abrupt of an environmental change this has been? And it turns out that it does. The natural cycles of light and dark that have existed on our planet for a long time, it turns out that they control a whole bunch of biological and ecological processes, both in humans and in other organisms as well. So we'll kind of start with animals here. So best estimates are that about 30% of vertebrates and 60% of invertebrates are nocturnal. So that's sort of the natural place to start, right? We would maybe expect that species that are active primarily at night would be the most affected by light pollution. And the study of how darkness or the lack of it affects different species actually has its own name. It's sort of its own subfield of biology. We call it scotobiology. And it's a really fascinating subject. Again, I'm not a biologist or an ecologist. So these next couple of slides are coming from someone who is really fascinated by this topic, but is by no means an expert. But what we are learning is that many organisms rely on either darkness or those natural cycles of light and dark to essentially to time in essential functions like foraging or mating or navigation. So I'll share a few examples from the scientific literature. The classic example, maybe one that you've heard of before, is sea turtles. So hatchling sea turtles navigate to the safety of the ocean using natural lighting cues. Namely, they are guided out to the ocean by moonlight and starlight reflecting off the surface of the ocean, right? That is sort of a natural cue that when the sea turtles hatch on the beach, it's sort of this natural cue to guide them out to the ocean and a place of relative safety. Many species of sea turtles will not nest on brightly lit beaches. So if you have beaches where there's a lot of development, lots of city lights along the beach, sea turtles will avoid those areas. And when they do nest on brightly lit beaches, the hatchlings, when they hatch, they will actually, they're essentially biologically programmed to move towards whatever the brightest source of light is that they can see. And unfortunately, on many beaches nowadays, that's not moonlight reflecting off the surface of the ocean, that is street lights and porch lights and cars and all sorts of different artificial light sources. So this image here is a GPS tracks of hatchling sea turtles. This was a study done in the 2000s down on the Gulf Coast somewhere. I don't remember exactly where this is from, but this was the location of the nest right here. And these black GPS paths here show the route that those hatchling sea turtles took. And you can see that in this case, every single one went inland rather than out to sea where they should be going. So not a great situation for the sea turtles. The effect of light on sea turtles has gotten, I guess, it gets a lot of press, right? Sea turtles are very charismatic. Many of the species affected by light pollution are, shall we say, less charismatic than sea turtles, but are no less important from an ecological standpoint. So for example, many species of reef-forming corals reproduce only once per year. They release their eggs and sperm on the same night in sort of this mass spawning event. And the timing of that appears to actually be controlled by moonlight. And so light pollution in coastal areas can actually mask that natural lighting signal and prevent the corals from reproducing effectively. This has been identified as a potential contributing factor to the worldwide decline of coral reefs, especially in areas of coastline that are heavily populated where there's a lot of sky glow and a lot of light pollution. Obviously, there's a lot of factors behind the decline of coral reefs, but this may be a component of it. Another example, dung beetles, right? Who doesn't love dung beetles? Biologists have discovered that some species of dung beetle actually appear to use the light of the Milky Way as a navigation aid, as an orientation marker. And so decreased visibility of the Milky Way, doesn't take a whole lot of sky glow to wash out the Milky Way, implies that the beetles lose their ability to orient themselves. And as small as they are, dung beetles are considered a keystone species because of their ability to facilitate decomposition and nutrient cycling. And that's true of many of the species that have been found to be impacted by light pollution. Many of them perform really important services for our ecosystem, like pollination or decomposition. Things that can have kind of ripple effects throughout the entire ecosystem. Insects are a great example. Many insects are attracted to light. And so artificial light at night or light pollution sort of functions like a vacuum cleaner. It's able to suck those organisms kind of out of their natural habitat. Let's not forget plants. So artificial light has been associated with changes in sort of plant physiology as well. Artificial light has been associated with earlier tree bud burst in the United Kingdom, the study cited here. Usually tree bud burst is controlled by kind of temperature and day length or photo period. And if you have trees that are leafing out or producing buds kind of earlier in the year due to light pollution, that can increase the risk of things like frost damage. This is a really interesting photo right here that kind of illustrates how much impact light can have on plants. This is actually a photo of a soybean field in Alabama. And it's a little hard to tell, but there's a street light right here, right along the fence line of this soybean field. And this photo was taken late in the year, so most of this field has been harvested already, except for the plants within a couple dozen meters of this street light. They're still fully leafed out. They never went to seed in this case. The exposure to this artificial light basically prevented them from going to seed. You can actually see, it's amazing here, you can actually see the outline of the flagpole, or not the flagpole, the light pole the shadow of the light pole right here, and how even the soybeans that were in the shadow of the light pole sort of behaved normally, whereas all of these other soybeans that were exposed to the light kind of clearly see that there's something different going on here, right? So that's essentially kind of a little bit of lost crop area for the farmer, with those soybeans exposed to light, never going to seed. I could kind of keep giving examples. This is a really active area of research, but instead I'll just kind of show this interesting graph here. This is the number of publications per year in the artificial light at night research database. So this is a database of peer-reviewed research on light pollution and its effects on the natural world. So prior to 1990, there was relatively little research on the effects of light pollution. So prior to 1990, there had been only about 200 scientific studies written on light pollution. Most of those, again, were in astronomy. And throughout most of the 1990s and 2000s, really only a handful of studies per year. Not until around 2008 or so did research into the effects of artificial light at night really start to take off. And you can see the last few years we've had 300, 400, 450 peer-reviewed scientific papers being published on this topic every year. So we know a lot more now than we did even a decade ago. What has become clear is that all of our artificial light, even at pretty low levels, affects the physiology of plants and animals and animal behavior. There's still a lot that we don't know. We don't know a lot about thresholds, about kind of exactly how bright or how extensive light pollution has to be before it starts to impact a particular species. And we don't really have a great sense of how light pollution affects like the long-term success or survival of species. There's definitely examples where it's clearly bad, the sea turtles being a good example, but in many other cases, it's sort of unclear. So for example, if a dung beetle loses the ability to navigate by the Milky Way, does that actually impact the survival of that dung beetle? Does that affect the number of dung beetles or their success at reproducing over time? We don't really know. That's still very much an open question in scotobiology. We don't know how light pollution kind of affects the evolution of these species over time. Now, I should say not all of these articles are about effects on animals or ecology. Another big area of research is the impact of artificial light at night on us, on humans as well. So even though we are not nocturnal, as humans, we've still evolved in that natural cycle of day and night. And like many other life forms, humans adhere to a circadian rhythm, right? Our biological clock, a sleep and wake pattern that is governed by those natural cycles of light and dark. Too much artificial light at night can disrupt that cycle. So many of us now live in these brightly illuminated environments 24 hours a day. We're not just talking sky glow here. This is a photo of a house just being bathed in light from a billboard alongside the freeway. Hopefully that house has good blackout curtains or some way to prevent that light from spilling over inside the house. But we're really starting to see that, excuse me, exposure to too much artificial light at night changes human physiology as well. This is where we need to talk a little bit about light spectrum. So a spectrum is basically just breaking down light into its component colors. So for example, here is the spectrum of sunlight, the sun. And we can see that sunlight kind of consists of all the different colors of visible light here: red, orange, yellow, green, blue, indigo, and violet. And we can see that sunlight, sort of the most intense colors in sunlight are sort of blue and green here. We say that the spectrum of sunlight peaks in the blue and green. So we've got kind of color on the horizontal axis here, and then the vertical axis is relative intensity. So when you're looking at sunlight, what's the relative intensity of all of these different colors? Let's contrast that with moonlight for a second here. So this is the spectrum of the sun. Here's the spectrum of the moon, which is our kind of one natural source of bright light at night. For the most part, the spectrum of moonlight is broadly similar to sunlight, which makes sense. When we look at the moon, we're just seeing sunlight bouncing off it back to our eyes. The moon is not hot enough to emit its own visible light, so we just see reflected sunlight when we look at the moon. So the moon spectrum looks broadly similar to sunlight. The one big difference, though, is notice there's a lot less of that blue light. Moonlight is sort of depleted in those blue wavelengths. And that has to do with essentially what the moon is made of. Not all colors of light are reflected off of the moon's surface equally. If we start thinking about the spectrum of artificial light, though, it can be very, very different. So here's the spectrum of what you would see in the hardware store or at Walmart as labeled as a cool white LED. This is a LED lamp that you might find in a street light or an office building. And it's sort of supposed to mimic natural sunlight or daylight. But as you can see, it has a very different spectrum from our natural light sources, right? Notice this huge blue spike, lots and lots of blue light in this LED, the spectrum of this LED bulb, relative to natural sources of light like the sun and the moon. And when it comes to humans, that blue light is really the concern. We've known for a while that blue light, exposure to a lot of blue light at night, inhibits our body's production of a hormone called melatonin. And we are exposed to a lot of blue light at night at a time when there really aren't any natural sources of blue light. So for example, all of our electronic devices emit a lot of blue light. Here is the spectrum of, this is the spectrum of my cell phone or my smartphone screen right here. Again, we see that really high intensity of blue light relative to a lot of other colors. Many devices nowadays have a night mode that's supposed to cut back on blue light for exactly this reason. So here is the spectrum of my phone screen in night mode. I can't really tell the difference. There's still just a ton of blue light here. It doesn't seem to have changed things very much. There's evidence that some of these blue light blockers or night mode features don't actually cut back on the blue light very much, if at all. But so there's lots of people who, especially people who work at night, who are basically bombarded by blue light all the time at a time when their body is not used to it. And I said earlier, I'm not an ecologist. I'm definitely not a medical professional. So I'm going to kind of give you the words of people that are here. The American Medical Association, in 2016, the American Medical Association sort of developed this summary of research into the effects of artificial light at night on humans and human health. And this is basically their concluding paragraph here. Pervasive use of nighttime lighting disrupts various biological processes, creating potentially harmful health effects related to disability glare and sleep disturbance. So basically what they found is that the risk of a whole host of negative health outcomes are observed to be higher in brighter areas, plus that there appears to be a causal link in many cases that is related to exposure to blue light and melatonin suppression. So this is still an active area of research, but in 2016, the American Medical Association actually recommended that we stop using these really blue-rich lights to light our cities. They basically said we should stop using these blue-rich LEDs as street lights because it's just exposing all of us to large amounts of blue light. So there's kind of potential human impacts as well here. Let's see, my computer froze here. Are you all still seeing the same slide?
No slides at the moment, Zach.
Okay,
Just you.
let's see here. Oh, there we go. All right, let me try to go back to sharing here. All right, is that better?
Looks good.
Working, okay. Not quite sure what happened there. So darkness, I think darkness is important, right? Darkness is a vital component of our natural world. It's something that many species rely on. In large amounts, it appears to have an impact on our health as well. As an astronomer, I would argue that it's being able to see the night sky is important. Without the sky, astronomy becomes very difficult. Already astronomers have sort of been forced to the edges of the Earth to find dark places to put their telescopes. What happens when we can no longer see the next asteroid headed towards us? There's also a lot of cultural heritage in the night sky. The night sky has been a source of inspiration for artists and authors and poets and scientists throughout history. Many cultures and civilizations have their origin stories rooted in the night sky. So beyond kind of all of these ecological and physiological effects, I think there's value in being able to just see the sky as well. Did I freeze again? No, okay. So let's come back to our sky glow map here. I want to talk a little bit more about kind of light pollution conditions here in our area locally. So how do we make maps like this? How do we measure light pollution? One way is to use satellites. Again, this map of sky glow right here is primarily based on satellite data. Satellites are great, but they have their limitations. Ideally, you don't want to rely on satellite data alone. We'd also like to be able to make some measurements from the ground to get a better sense of what's going on and to sort of calibrate what the satellites see with what conditions are actually like down here on Earth. There's a few different ways that we can do that. One of them is with this little thingy right here. This is called a sky quality meter. And it is, it's probably blurry for you, isn't it? Because it's blurring my my background. Let me see if I can undo that here. So I can actually, there we go, that's better. All right, so this is called a sky quality meter. It is a little device that basically measures the brightness of the sky. So you take it outside on a clear moonless night, you point it up at the sky, you press a button, and it takes a measurement and spits out a number. That number is in basically the same units that are on our sky glow map here. The colors on our sky glow map are telling us something about how bright the sky is. And that's what the sky quality meter is measuring as well. It's giving you a measure of how bright the sky is at the zenith straight overhead. So it's a handy little device if you want to get an idea of what light pollution conditions are like in your area. It's not a super precise instrument though. They have a lot of limitations that make them really tricky to use like in actual research. But there is a better way of measuring light pollution from the ground. It was actually developed by scientists with the United States National Park Service. So it just so happens that many of the darkest remaining places in our country are occupied by national parks. And if you run a national park, you care about light pollution because it has an impact on plants and wildlife. It has an impact on the scenery for visitors. And so in the 1990s, the United States Park Service started to kind of take note of light pollution for many of the reasons that we just talked about. And one of the neat things that they did was develop a really cool way of measuring light pollution and sky glow from the ground using a camera. And I want to show you some of their measurements because they're pretty neat. This is an example of a photo taken by this light pollution monitoring camera, essentially. It's a panorama, so a 360-degree panorama of the entire night sky that is then color-coded by brightness. So just like our sky glow map here, the sort of warmer colors, the greens and the yellows here, those are areas of the sky that are brighter. So in this picture right here, we can see that the kind of the brighter portions of the sky here, that's the Milky Way, our own galaxy. The thing is, we're not really interested in the Milky Way or the stars. We're interested in the amount of human-caused light. We're interested in light pollution. So here's the really cool part of this. Thanks to astronomers, we know how bright the stars are. We know how bright the Milky Way is. And so we can digitally subtract all of the natural starlight in the night sky from our photo. And the result is a panoramic photo of the entire sky that just shows light pollution. It just shows sky glow. So any color remaining in our photo here is unnatural light, is sky glow, essentially. And then any areas of our photo that are black, those are areas of night sky that are pristine, that are unaffected by human-caused light. So as you can see, the night sky from this location is very dark and very pristine. There's very little light pollution in this location. This measurement was taken from Capitol Reef National Park in southern Utah. It's about as close to true darkness as you can find these days. On a dark night, the human eye could see about 6,000 or 7,000 stars from this location, from a truly dark night sky. That's about the most stars that the human eye is capable of seeing. So if you ever read authors or poets talking about there being millions of stars in the night sky, they either have a telescope or they're lying to you. 6,000 or 7,000 is about the max. Let's come a little bit closer to home. Here is a measurement taken not very far away. This is a measurement of light pollution from Mount Rainier National Park. We've already subtracted the natural light here. So what we are seeing is light pollution. From Mount Rainier National Park, the entire sky is affected by light pollution to some extent. There's only about 3,000 stars visible from this location, right? So we've lost half of our stars. What's kind of sad is that this is I think what most of us would consider a dark sky here in the year 2022. You can see the Milky Way from here. If you were to drive up to this spot in Mount Rainier tonight and it was clear, drive up there, get out of your car and look up, you'd probably say, wow, right? Look at all those stars. This is a darker sky than most people have ever seen. Even though we've lost half of our stars. And that is sort of a reflection of how prevalent light pollution has become, that most of us don't know what a truly dark sky looks like anymore because it's so hard to find. And this phenomenon actually has a name. It's called shifting baseline syndrome. It's a sociological phenomenon in which each new generation perceives the environmental conditions that they were raised in as normal. And so as a result, our standards for the environment sort of continually get lower as we collectively forget what things were like in the past, right? So in other words, we've kind of become so accustomed to light pollution that we basically don't know any better. Here is the amount of light pollution from North Cascades National Park. So it's a little better, a little more remote up in northern Washington. And then our third and final national park in Washington, this is Olympic National Park out on the Olympic Peninsula. So kind of similar to Mount Rainier, really the entire sky is degraded by sky glow. So what can we do, right? We've talked about the effects of all of this light. There's still unknowns. We know enough to say that, finding ways to reduce light pollution, finding ways to use artificial light more wisely is probably a good idea for a number of reasons. One of which is money, right? Again, all of that light that just goes up into the sky is energy and money down the drain. The good news is this is really one of the, if not the easiest environmental issue to fix or mitigate. For a couple of reasons. One, the fix itself is simple. We're going to talk about that in a second. But two, unlike air pollution or water pollution, if you fix the problem, the light pollution goes away immediately, right? It's light. It travels at 300,000 miles per second. It goes away. It doesn't stick around like air pollution or water pollution. If you solve the problem, you actually solve the problem. The real problem is lights like this. So this is what lighting folks affectionately refer to as a glare bomb. Presumably the purpose of this light is to illuminate the sidewalk or maybe that fence in the background. But most of this light isn't actually doing that. A bunch of this light is going up into the sky. A bunch is going straight into our eyes. That's what we call glare. Glare is, if anything, harmful, right? If you think about driving down the highway at night and you're constantly being bombarded by the glare of car headlights, glare makes it harder to see at night. So only a small percentage of this light is actually aimed at the ground where it is needed. And we see this with all sorts of lighting. Billboard lights are another bad offender. For some reason, we light most billboards from below. We put these huge floodlights on the bottom of billboards, and most of that light just goes straight up into the sky. Some of it hits the billboard, but most of it just goes up into the sky where it creates sky glow. Then there's my favorite, or least favorite, I guess you might say, globe lights. You've probably seen street lights like this before. You think about this light in the middle here, right? We've got light going up, we've got light going sideways, we've got light going everywhere except down, which is presumably where that light is actually needed. So a lot of lighting is just poorly designed, doesn't make it easier for us to see at night, it just contributes to light pollution. So the most significant thing we can do to combat light pollution is to aim lights down where we actually need them. What we want to do is eliminate the light that is going up into the sky. And we can do that by using what are called fully shielded light fixtures. So here's kind of a schematic of what that looks like. So here's our ugly globe light over here on the left. That's sort of spewing light in all directions. In the middle here is an example of a partially shielded light. So it's a little bit better. The light isn't going straight up, but there's still kind of a lot escaping to the sides. A lot of street lights would be examples of partially shielded lights. And then on the far right here, an example of a fully shielded light where all of the light is directed down towards the ground. It's not allowed to escape sideways. It's not allowed to spill into the surrounding environment and not allowed to escape into the sky. Here's an example of what that looks like in practice. So this is a street somewhere in Canada, if I recall correctly. I can't for the life of me find where this photo came from. If it's yours, I apologize for using it without attribution, but it's a great example of really good lighting. You can see in this photo, there's a little bit of fog or smoke in the air, so you can really see how these street lights are aimed down, how they're fully shielded. And note as well that the street is still very well lit. Having a dark sky doesn't mean having a dark ground. If we are aiming our light down at the ground, we can get very good illumination. We can get all of the light that we need for safety and security on the ground pretty easily. And I want to reiterate that because whenever you start talking about reducing light pollution, a lot of people, especially talking to businesses with a lot of lights or city councils that are in charge of things like street lights, start talking about reducing light pollution, and what a lot of people hear is turn all the lights off, right? And that's not the solution for obvious reasons. We need light at night for a lot of different reasons. But there is this societal belief that more light equals more safety. What really improves safety is good lighting, right? Well-designed lighting. So here's an example using our glary light from before, right? We've got lots of light here. It's super bright, but that glare actually makes it harder for a human to see in this situation. Our eyes aren't very good at seeing in environments where there's really bright areas and then really dark areas side by side. So you might not have noticed, for example, that there was a person standing in that gate behind the light, right? Because you can't tell unless you get rid of that glare. Here's another example, 4 street lights, 2 unshielded on the left here, and then 2 shielded street lights on the right. There's a person standing under all 4 of these lights. Notice how it's much easier to see the ground, to see that person under the fully shielded lights that are aiming their lights down at the ground. So the takeaway here is that good lighting not only reduces light pollution, but it also can improve safety and visibility as well. Lights that are fully shielded generally provide kind of more even illumination, less glare, and help everyone see better, because that's really the goal, right? We need light at night, but we need it on the ground, not up in the sky. Many times we can actually save money and energy as well, right? If we're not losing a whole bunch of our light to space, right, we can use a lower wattage light bulb and save on energy and money as well. Now I'm going to immediately undermine myself and say that in some cases, maybe you can turn some lights off. So here's a picture of some flag poles on a university campus somewhere in the Western United States. It's customary to shine a light on flags that remain up at night, okay? Notice in this picture, though, there are no flags on these flag poles, yet we've got 5 bright spotlights here on the ground, just shining hundreds of watts of light straight up into the sky. If there's a better example of wasted light than that, I haven't found it. So we can turn those lights off, right? It's not going to impact safety and security. It's going to reduce sky glow. It's not going to have an impact on safety and security, right? So another principle of good lighting is, right, only light things that need to be lit when they need to be lit, right? Does this parking lot need to be lit? Maybe sometimes, right? Maybe if a car shows up, arguably not in this scenario right here where there's nobody in this parking lot. That's the nice thing about some of the newer LEDs is that they have timers and motion sensors that can help turn lights off when they are not needed. And then last but not least, using warmer colored bulbs. So we talked earlier about how blue light has a greater impact on human physiology. That may be true with some animal species as well, though it seems to vary a lot. Blue light does cause more sky glow, though. The sky is blue because our atmosphere preferentially scatters blue light. And that doesn't change at night. If you shine a blue light and an orange light up into the sky, the blue one's going to cause a lot more sky glow. So the color of light that we use at night matters as well. Just for example, here is the spectrum. Look at a couple more spectrums here. Here's the spectrum of a high pressure sodium street light. So this is your kind of classic deep orange colored street light that has been in use for decades. High pressure sodium street lights, very little blue, which is good. The problem is that in a lot of cases, high pressure sodium is being replaced by LEDs. In sort of the best case scenario, by a relatively warm LED light. So this is the spectrum of a warm white LED. More blue than high pressure sodium, but not too bad. In a worst case scenario, these high pressure sodium lights are being replaced by cool white LEDs that are almost all blue. And everything else being equal, this light right here is going to cause 3 to 5 times as much sky glow, as much light pollution as our high pressure sodium light. So LEDs can be good for light pollution or they can be bad. It really depends on, are they shielded? Is the light aimed down at the ground? And how much blue light is there? Those two factors are really kind of what determine how light pollution friendly a street light is. So those are kind of the 3 big things: aim lights down, turn off lights if they're not really serving a purpose, if they're not doing anything, and use warmer colored bulbs. And if you do that, it does make a difference. All we need to do is look at our sky glow map and compare a couple cities of similar population, but with different approaches to lighting. So here is a screenshot from that sky glow map of Flagstaff, Arizona, and Cheyenne, Wyoming. Similar population. Flagstaff is a little bit bigger. Drastically different light pollution footprints. In fact, measurements by the National Park Service show that the night sky, there's Yakima for comparison, the night sky outside of Flagstaff is about 1/10 as bright as the night sky over Cheyenne, Wyoming. Even though Flagstaff has more people, it has 1/10 the light pollution emissions of a smaller city. The difference is that Flagstaff follows all of the principles that we just talked about. It has really good lighting. There's a bunch of observatories, a bunch of astronomical observatories in Flagstaff. And the city realized a long time ago that to keep them there, they needed to make sure that things remained relatively dark. And they've done a really good job of that. So this is kind of what I meant earlier, that more people doesn't necessarily mean more light pollution, right? If a city or a town is really conscious about how they use lights, it's possible to have a very small light pollution footprint, even with a fairly large city. So back in 2001, Flagstaff was actually named the world's first international dark sky city by the International Dark Sky Association. So this is a nonprofit that basically promotes the protection of natural darkness. So the IDA has certified hundreds of cities and parks and natural areas as dark sky places. These are places that sort of have committed to using light prudently and keeping the sky and the environment dark. So you can go to their website and see kind of where all of these dark sky places are. There are none in Washington at the moment. So I'll issue that as a little bit of a challenge. Hopefully we can get an international dark sky place here in Washington at some point. That would be really, really great. So that is about it. I just wanted to say, if I have piqued your interest at all, a few ways that you can get involved. One is obviously to actually look at the lighting on your home or your business and think about whether it's kind of serving its intended purpose or if it could be retrofitted to be more light pollution friendly. Obviously, not all of us live in places where we can do that easily. If you rent, for example, switching out lighting on your residence may not be possible, at least not easily. Something else you can do is keep an eye out for proposed changes to municipal lighting. So cities will often replace a whole bunch of streetlights all at once. And community input can affect the choices that a city makes. When I lived in Utah, the town that we lived in decided one year they were going to switch all of their streetlights over to LEDs. Initially, they were going to choose one of those nice bright blue LED lights. After some citizens provided comment, they ended up choosing a warmer, oranger LED instead. So kind of keeping tabs on your local city council or county commission for changes being made to streetlights can be a good thing to do. You can also get involved in monitoring light pollution. So there's this really cool citizen science project called Loss of the Night. This is run by a light pollution researcher in Germany, Chris Kaiba. It's an app, so you can download this app for your phone, and it actually walks you through looking for different stars in the sky and seeing if they're visible or not in order to basically determine how dark your sky is, how much light pollution is in your sky. So it's a great way to go stargazing and contribute to our knowledge of light pollution at the same time. But you can also use these sky quality meters to measure night sky conditions. I'm working right now on identifying locations around the Yakima Valley that we can do sky quality meter measurements and make repeat measurements over time to kind of see if and how light pollution conditions are changing in our areas. So if you're interested in getting involved with that, or taking a closer look at what kind of lighting we have here in the valley, feel free to contact me. My contact information is on this slide. It's my personal and work email there. If you ever have any questions or want to get involved in this sort of work, feel free to contact me. Thanks for listening. It went a little longer than planned there, but happy to take any questions, comments, or complaints that you might have.